example, I am going to create here a molecule of water. What happened with the molecule of water? Let me try to check what happened with water. All right, water is oxygen and 2 hydrogens. Let me I make a drawing about that molecule, the molecule of oxygen and hydrogen. All right, how many electrons have oxygen in the last orbit? Oxygen in the last orbit have 6 electrons. Okay, let me check. 1, 2, 3, 4, 5, and 6. Remember about the octet rule. What states the octet rule? That all the elements try to complete 8 electrons in the last orbit or 0 in order to be stable. Okay, good, very good. How many electrons have hydrogen in the last orbit? Hydrogen in the last orbit only have 1 electron. What element in between oxygen and hydrogen have more electronegativity or high level of energy? According with the periodic table. Oxygen is located here. And hydrogen, here. Of course, oxygen have more level of energy, more electronegativity. Okay, in that case, oxygen in the future attract electrons from hydrogen, and hydrogen release. Okay, hydrogen release this electron, and the other hydrogen release the other one, and at the end of the day, oxygen complete 8 electrons, hydrogen completes 0, and the other hydrogen 0, and the molecule is stable. What is the name of the molecule? H2O, and this is water. Water is a perfect molecule. Water is a molecule fully stable. Let me try to create another molecule or compound stable. Try to think in the environment, other molecule that is stable. What about the oxygen that you breathe? The oxygen that you breathe is, the molecule is O2. And is stable that molecule? Yes, it's stable. Let me check why that molecule is stable. I have 2 oxygens. And each oxygen with 6 electrons in the last orbit. And I have the other oxygen here with 6 electrons in the last orbit. What is the situation in this case? They share a couple of electrons. And all the time, both of them have 8 electrons. That relation is a covalent reaction. And the previous one, this one is ionic reaction. We are going to learn later in our class of corrosion that this relation is permanent. The ionic reaction is permanent. And what about this one, the covalent reaction? This is temporary. Okay, it's temporary. What is the meaning of that? This is important. For that reason, the oxygen in the environment, that relation in between 2 atoms of oxygen is not permanent, it's not strong, it's temporary. For that reason, in the environment, it's easy to separate those 2 oxygens. We are going to check carbon dioxide, CO2. All right, I am going to check 1 carbon here in the middle with 4 electrons in the last orbit, because carbon is located here in group number 4. And I am going to draw 2 oxygens, and each oxygen with 6 electrons in the last orbit. Each oxygen with 6 electrons in the last orbit. Okay, 6 electrons in the last orbit. Okay, let me check what is the element with more energy. Oxygen, because oxygen is in group number 6. And the element with less energy is carbon. Okay, what is the meaning of that? Right now, in this relation, oxygen tries to attract the electrons from carbon in order to complete 8 in the last orbit. That's the situation. Those electrons from the carbon goes here, and the other one goes over there because oxygen have more energy. This one completes 0, this one completes 8, and right now the molecule CO2 is a perfect stable molecule. What happened with the molecule of CO, carbon monoxide? CO, carbon monoxide. I have only one carbon and only one oxygen. Let me check the oxygen with 6 electrons and the carbon with 4. Those two goes here. But what about these ones? That molecule is stable? No, that molecule is not stable because there are two electrons free. And those two electrons from the carbon in the environment try to separate molecules of oxygen, try to separate the O2 in order to stabilize the equation, but the single oxygen produce pollution because the single oxygen will be attracted from fluorine, chlorine, or sulfur and create molecules not good for the environment. How many electrons have oxygen in the last orbit? 6. How many electrons need oxygen to complete 8? 2. Okay. Suppose that oxygen have in front 2 metals, copper and zinc. What element for the oxygen is better to attack? The copper or the zinc? Let me check. If the oxygen attack the zinc, immediately complete 8 and finish. Finito. If the oxygen attack the copper have 3 electrons in the last orbit, and the oxygen need 2. Immediately the oxygen need call other oxygen, and the copper call other 2 additional coppers in order to create this molecule. The molecule this is the oxide of copper. This is the oxide of copper. What about if the oxygen try to attack the aluminum? Exactly the same. Exactly the same. There are necessary 2 molecules, 2 atoms of aluminum and 3 atoms of oxygen in order to create the oxide of aluminum. It's complicated. What happened when the oxygen attacked the zinc? When the oxygen attacked the zinc, immediately the situation is this. When the oxygen attacked the zinc, the oxygen have 6 electrons in the last orbit. And zinc 2. What happened? What element have more energy? Oxygen. What element have less energy? Zinc. Immediately the oxygen attract the 2 extra electrons and the zinc release those 3 electrons. What is the name of the element that release the electron, that donate the electrons? This is the anode. This is the anode. And what is the name of the element that attract the electrons? This is the cathode. This is the cathode. What is the charge of the cathode? Is negative. What is the charge of the anode? Is positive. Why the anode is positive? Yes, because in this particular example, zinc released 2 electrons. When the element release negative charge, become more positive. And what about the other one? The other one attract 2 extra electrons. Right now the charge is more negative. I explained the phenomenon of zinc, like a protector of other metals, with a funny example. Suppose that you have a party for kids, little kids, and the party is in this room, and I have 3 groups of tables, and the door is in this corner, and I am going to organize the room for the party, and I am going to put in the group of tables in the middle only donuts of a lot of sugar, strawberry donuts in the middle. And in the group of tables on the left side, I am going to locate vegetables, broccoli, vegetables. And in the group of tables in the other side, I am going to put place with fruits. Okay. Ready? I have three groups: vegetables, donuts, and fruits. And I am going to open the door of the room right now, and the kids enter in the room. What group of tables disappear in fraction of seconds? The middle ones with the donuts. The donuts disappear in 2 minutes. Okay. What is the next group of tables in preference for the kids? Okay, the fruits. A lot of bananas. Okay. And what is the last one? The vegetables. All right. What is the meaning of that? In our boat, if I am the oxygen and I am checking in the bottom of the boat is on the water, and I am the oxygen on the water, I want to attack that boat. Let me check what is the metal that I love it. What is the donut for me? Oh, the zinc. And I go and I attack the zinc where I have zincs in a typical boat. Oh, I have zincs on the shaft. I have zincs at the end of the propeller. I have zincs on the rudder. I have zincs on the flaps of the twin tabs. Yeah, those are the most common zincs. And of course, I have the main zincs on the transom of the boat. The oxygen attack all of those things, and the rest of the metals, the shaft in perfect condition, the propeller in perfect condition, the rudder in perfect condition, the flaps in everything in perfect conditions, because the oxygen attack the pieces of zinc. Nice. What happens when the zincs are fully eroded, completely eroded? Of course, if the zincs are gone, the oxygen starts to attack the vegetables slowly, and the copper will be corroded, the steel will be corroded, slowly, but will be corroded. For that reason, you need to keep your zincs like new ones, in perfect conditions, in order to protect the other metals. Is clear? Okay. Remember, carbon, silica, and germanium, those three elements are considered semiconductors. Important factor. Where are located those three elements? In carbon, silica, and germanium. Those three elements are located in the group number 4. Those elements produce excellent structure, because the people ask about why the carbon fiber and the fiberglass, the structure is strong. Let me demonstrate why. Suppose that we have a carbon fiber. We have the structure of the mat of carbon fiber. That heavy structure is basically carbon. Atoms of carbon together. Let me check what happened in that structure. I have carbons, I have carbons, I have carbons, pure carbons. And let me verify how many electrons have a carbon in the last orbit. 4 electrons, no? According with the periodic table, it's located in the group number 4, is 4 electrons. Each atom have 4 electrons in the last orbit. What happens if I put more carbons and more carbons and more carbons and more carbons? Yes, all of them, they have 4 electrons in the last orbit, and they can create covalent reactions in between one and the other one. They share electrons. They share electrons. At the end of the day, each atom
complete 8 electrons in the last orbit. Complete 8 electrons in the last orbit. 1, 2, 3, 4, 5, 6, 7, 8. And the structure is a perfect structure. It's strong because it's not possible introduce additional elements because the structure is perfect. The bond of the system is perfect. Each atom complete 8 electrons in the last orbit because share other 4 electrons with other 4 carbons around the structure. This is a perfect structure. It's a wonderful structure. For that reason, when you cover that mat with a resin, you have a strong structure. The carbon fiber is wonderful, is perfect. We are going to study later the carbon fiber, and we are going to study why the carbon fiber reach tensile strengths superior than the steels and torsion strengths superior than steels. For that reason, the majority of the bicycles today are fabricated in carbon fiber. The chassis of race cars are fabricated in carbon fiber. It's because that structure is perfect. It's perfect because you don't have the possibility to introduce any other element in between because the structure is completely closed. It's hermetic. Exactly the same situation is with silica. With silica, it's basically the same. You have silicas. Silica and carbon are in the group number 4. And once again, all of them, they have 4 electrons in the last orbit, and they produce covalent reactions with the other ones. And complete 8 electrons in the last orbit. This one is used for fiber because the silica mat is that one, is used in the fiberglass. This is used in fiberglass. Because remember, glass is silica, glass is sand, glass is silica. This is for fiberglass, and this one is for carbon fiber. This is for carbon fiber. Oh, the fiber in the carbon fiber structure is pure carbon. The mat is that. In fiberglass, the fiber is this mat, and is also a perfect structure. The only difference between both of them, between carbon fiber and fiberglass, is the resin. In carbon fiber is recommended use epoxy resin, and in fiberglass normally the people use polyester resin. Polyester resin with fiberglass and epoxy resin with carbon fiber. That's the difference in between both structures. But both of them use those elements located in the group number 4, carbon, silica, and germanium. When the metal is oxidized, because the oxygen attacks the metal, produce the powder over the metal. That powder, the oxide of that metal, is a perfect isolator. With those powders, you fabricate ceramics. Ceramics in different ways. Ceramic like this, with the oxide of copper, with the oxide of iron, with the oxide of aluminum. A lot of oxides are used to fabricate ceramics. And the ceramics are perfect isolated. It's incredible, no? The metal by itself, perfect conductor. But when the metal is attacked for the oxygen, produce the ceramics, the powder. That powder in different colors, depending on the metal. Yes, for example, copper produce 3 different type of oxides in 3 different colors. You see the colors. This is a ferrous oxide, a ferric oxide. Yeah, depending of with how many electrons work the iron in the last orbit, when the iron is combined with the oxygen, produce a ferrous oxide or ferric oxide. Yeah, remember that the iron work with 1 or 3 electrons in the last orbit. Okay, but we are going to study later that situation. This is the situation with the oxide. when the oxygen attacks the metal. Okay, suppose that we have oxygen and we have iron. And what is the formula for the oxide of iron? The oxide of iron is... what is the meaning of that? Is that you need 2 atoms of iron per 3 atoms of oxygen to create that molecule. The molecule of oxide of iron. That molecule is stable. Yeah, but it's a lot of combination, no? It's 2 irons per 3 oxygens. Yeah. Let me check what happened in this particular. How is that formula? I have 3 oxygens. I have 3 oxygens, and I have 2 irons. And the iron have 3 electrons in the last orbit. The iron have 3 electrons in the last orbit. And let me check the oxygens. The oxygen have 6, no? The oxygen have 6 oxygens in the last orbit. 6 oxygens in the last orbit. And each iron, each oxygen need 2 additional to be stable. What element have more energy in that combination? Oxygen, because oxygen is located in that corner, and iron is located here, less electronegativity. Oh, the element with more electronegativity, with more energy, absorb the electrons. In that case, this one and this one migrate over there, and this one migrate here, this one migrate here, and this over there. That's perfect. And now the molecule is stable, and this is the molecule of oxygen. Nice, no? This is the procedure to create those molecules. This is the molecule of oxygen. But it's complicated, no? Because the oxygen needed wait until other 3 oxygen be clear. Hey, my friend, come on. I have a party with other 3 irons. Can you call other guy? It's complicated. Let me check what happened if the oxygen found a zinc on the environment. What happened if the oxygen find a piece of zinc on the environment? This is the situation. This is the zinc, and this is the oxygen. The oxygen with the 6 electrons in the last orbit, and the zinc with 2 electrons in the last orbit. Once again, what element have more energy? Oxygen is located in that corner, and zinc less energy. Okay, in that case, the zinc release the electrons. The zinc release the electrons over there, and the oxygen complete A, and the zinc 0, and the molecule is this. That molecule is too simple. In other words, for the oxygen, it's better when the oxygen find a piece of zinc, because attack directly. The oxygen don't need call other 3 guys and other. No. It's not complicated. It's simple. Attack the oxygen. Yes, my friends. For that reason, you can put a piece of zinc over the copper or over the iron, over the aluminum, and the oxygen attack the zinc and not attack the aluminum. In this picture, if you remember, we have the tensile strength. That's the yellow point. This is the maximum strength supported by the metal before the metal is broken. Look at iron. It's 200,000 psi before the metal is broken. Before 200,000 psi is the elastic area. This is the highest in comparison with the rest of the metals. What is the second one with high tensile strength? Nickel. For that reason, the alloys of metals with nickel have excellent tensile strength. You remember nibral? The alloy of the propellers is nickel, bronze, and aluminum, that alloy. That alloy have a tensile strength superior than steel. Yes, the propellers in Nibral, they have superior tensile strength than steel. And what is the metal with less tensile strength? Oh, lead, 10,000. Yeah? Lead is malleable. The elastic area of lead is practically nothing. A little deformation and is deformated permanent. Lead is heavy with a lot of neutrons in the nucleus. Lead is good to storage electrons, but it's not good in tensile or torsional strength. That's not good because the yield point, the breaking point is too close. Alright? You like? That picture is very important. That picture is in your book of intro, in the intro to marine class. Alright, my friends, we are going to continue with steels with high strength, with high capacity, high strength. Those steels, they have this nomenclature: AH32, DH32, and the rest of those are steels with high strength. We are going to consider the curve of deformation of a steel. The curve of deformation of a steel is this. This is the deformation, and this is the strength in psi, the strength applied to the steel. And the curve is like this. And this is the yield point. And this is the ultimate strength. What is the meaning of that? In this area, the deformation of the material is elastic. What is the meaning of that? You apply force until this point, and if you remove the force, the metal returns to the original position. It's elastic. After this point, the deformation is plastic. The deformation after that here is a plastic deformation. In this point is the break point. It's the point when the metal is fractured. In steel, that point here is 200,000 psi. Steel is an iron alloy, have the maximum tensile strength. Iron have the maximum tensile strength in comparison with other metals. You remember that picture? This is the picture that we used in our class of intro. In that picture, we are going to analyze that the iron in the bottom have the maximum tensile strength, 200,000 psi. Oh, what is the meaning of that? You apply 200,000 psi, and in that point, the metal is fractured. Before of that, if you remove, before a little less, 180, if you remove your force, the metal returns to the original position because it's in the elastic area. Alright? This is the meaning of that, and the breaking point is the point where the metal is fractured. Alright? What is the other metal in that table with high tensile strength? It's nickel. Oh, nickel. Nickel is wonderful. For that reason, the alloys with high content of nickel, there are alloys with high tensile strength. Yeah? In ferrous and non-ferrous alloy. You remember a non-ferrous alloy with high content of nickel, famous in marine application? Yes, Nibral. Nibral, that alloy is a perfect alloy with high content of nickel. That alloy have a maximum tensile strength superior than iron. Normally, the alloys have superior characteristics that the metal separated. For example, there are alloys, steel alloys, with superior tensile strength than iron. Yes, there are alloys with 230,000 psi of maximum tensile strength. And there are ferrous alloys with maximum tensile strength superior than steel, because it's combination of different metals with high tension strength. For example, nickel is an element with high tension. Titanium, tungsten. What happens if you if you create an alloy with those three metals? You have an alloy with high, ultra high tensile strength. This is the ability of the metallurgical engineers to discover what components in the alloy increase that property or decrease other property.
What is the meaning of the ozone? What is the formula for ozone? Is O3. Is O3. You remember that the oxygen, the molecule of oxygen, is two atoms of oxygen, the single oxygen. O2 is two atoms of a single oxygen. You remember how many electrons have oxygen in the last orbit? Oxygen have 6 electrons in the last orbit. Is in the group number 6. Oxygen, sulfur, selenium, tellurium, polonium. Oxygen have 6 electrons in the last orbit. Okay, and both atoms share a couple of electrons, and both of them, at the end of the day, they have 8 electrons in the last orbit, the octet rule, and that molecule is stable. But that relation is not strong. It's not permanent because it's covalent. You remember? It's covalent. It's not strong, it's not permanent. It's covalent. For that reason, separate that molecule. Separate that molecule is easy. And this is the problem with the ozone. Yeah, this is the ozone. There are two types of ozone. The ozone created close to the surface of the Earth is bad ozone. And the ozone in the stratosphere, in the second layer, is a good ozone. And now I am going to explain why, for what reason. What is the meaning of the ozone? Ozone is ready to react, is good for cleaning purposes, for disinfection, but it's not good if you breathe the ozone because damage your lungs. That's catastrophic. And also, the ozone close to the surface of the Earth corrode building materials, monuments, natural rocks, everything. Corrode everything. It's highly corrosive. The ozone close to the surface of the Earth is a detergent and clean and attack everything. That's not good. How is produced the ozone close to the surface of the Earth? By man's hand, by your hands, for you. Yes, with your car, with your motorcycle, with the incomplete combustion of those engines, gas and diesel. Yes, let me explain why. I have an example. With you remember that the cars, gas and diesel, they produce different oxides, oxide of carbon, sulfur, phosphorus, yeah. We are going to check one of these. For example, the oxide of carbon. There are two oxides of carbon. There are two oxides of carbon. Carbon dioxide and carbon monoxide. Why carbon dioxide is not bad? Because that molecule is stable. That molecule is stable. You remember, you have a one oxygen, other oxygen. Each oxygen have 6 electrons in the last orbit. Okay, 1, 2, 3, 4, 6, the black ones. And the carbon have 4 electrons in the last orbit. 1, 2, 3, and 4. Which one have more energy? Oxygen, because oxygen is located in that corner of the periodic table with more electronegativity. Oxygen need or attract 2 electrons from the carbon. Okay, this electron is going here, the other one is going here, this one is going here, the other one is going here, and this one complete 8, and carbon 0. And that molecule is stable. That's clear? Carbon dioxide is stable. It's no react. It's solid particles. Only produce pollution because it's solid particles. Yeah, carbon. Carbon dioxide is accumulated in the filters. That black area is carbon dioxide. All right, but no attack. Carbon monoxide, the second one, is 1 atom of carbon and 1 atom of oxygen. The oxygen with 6 electrons need 2. Okay, those 2 electrons goes over there, and those extra 2 electrons are free. They are free. That molecule is not stable. That molecule needs other single atom of oxygen to be stable. That molecule is checking in the environment for an extra oxygen. The oxygen that you breathe is O2. The O2, the molecule is not strong. You remember, it's covalent. When the carbon monoxide passes in front of a molecule of oxygen, separate the atoms and attract 1 atom. That atom of oxygen enter here. That atom of oxygen enter here, and the carbon release those electrons, and right now the molecule is stable. But the other single oxygen right now is free in the environment and is combined with other O2 and produce O3, ozone. And that ozone is bad ozone because it's close to the surface of the earth. That's the explanation.